Hi, my name is Carlos and I'm a final year IGI PhD student. I am researching at the intersection of virtual reality and artificial intelligence for my PhD thesis, which is an interesting place to be. Let me explain it further. Current virtual reality games offer a renaissance of motion controls, where players can move freely to explore and interact with the virtual environment. However, this freedom can easily be constrained due to a variety of technological limitations that can affect negatively the player experience. If a player wishes to freely interact with a virtual agent or engage in an elaborated sword-fight combat with an enemy, they will quickly find how the game doesn't quite understand much of the movements and expect them to move in a particular way. Motion-controlled video games generally rely on scripted solutions when interacting with elements in-game, a solution that works well for many designs, but heavily limits the design space. These can potentially translate into frustration and affect negatively the feelings of presence, immersion, or enjoyment, something we will want to avoid at all costs when designing video games. One of the solutions to make computers more aware of player movements is the use of machine learning models. Neural networks can be trained to learn how players move in virtual environments and detect richer and more expressive interactions. However, traditional methods of machine learning engineering require an expert to create, train, and deploy the model into the application. This process is slow and can create a bottleneck in game studios where designers constantly produce and iterate over playable prototypes. In addition, movements are so diverse among players that players themselves might want to customize how movements are recognized to fully express themselves. The solution I am exploring in my PhD thesis, then, is to directly give game creators the power to quickly create, train, and iterate over machine learning models directly in the game engine. This process is known in academic literature as interactive machine learning, and the tool we created to allow this process in game development is called InteractML. InteractML brings machine learning visual scripting into Unity, empowering game creators to develop novel gameplay mechanics and motion control schemes without writing code. They can create machine learning models by joining nodes together and visualize in real time the data from a Unity scene in the graph. Furthermore, players can interactively retrain the neural network in the final build of the game to fit their particular movement or gameplay style. InteractML is offered free and open source under an MIT license, so if you are interested, please visit the website for more information. We recently followed this approach and developed a virtual reality prototype analyzing player body, eye, and lip movement using a neural network for the HTC Vive Developer Jam 2020, where we won the first prize in the competition, all using InteractML. Now, there are so many possibilities in quickly and iteratively training neural networks in virtual reality games that we actually find that we don't know much of what kind of games and interactions can fully leverage the power of our machine learning models. Therefore, in my latest study, we gave game developers the power of InteractML to create machine learning-powered VR games and run a series of remote workshops to understand the design space of such interactions. There will be a paper coming out soon of this study, so please reach out if you are interested. In the remainder of my PhD, I plan to further explore how different machine learning algorithms affect these designs and how, once implemented in a playable prototype, they affect the player experience. If you want to get in touch, please follow me on Twitter at carlotes247 or write me an email in the address below. Thank you very much for listening, and I hope you enjoyed this very little buzz for the IGI Conference 2020. Thank you.